Hello, everybody. We are starting section 2.2, which is organizing quantitative data. We're done with organizing qualitative data and representing them with graphs. Today, we are going to organize discrete data in tables, construct histograms of discrete data, organize continuous data in tables, and construct histograms of continuous data. The first step in summarizing quantitative data is to determine whether the data are discrete or continuous. If the data are discrete and there are relatively few different values of the variable, the categories of data, which we call the classes, will be the observations as in qualitative data. If the data are discrete, but there are many different values of the variables, or if the data are continuous, the categories of data, the classes, must be created using intervals of numbers. So if our data is discrete, then we follow the same steps that we followed when we organize the qualitative data. But if the data is continuous, then we need to create intervals of numbers. Here's an example to illustrate the different ways to organize discrete data in tables. The following data represents the number of available cars in a household based on a random sample of 50 households. We want to construct frequency and relative frequency distribution. If you notice our set of raw data, we only have relatively few different values. So we have the value 0, 1, 2, 3, 4, and 5. That's not too many. That means we're going to organize our discrete data in a table in the same manner we organized our qualitative data. In our first column, we put the categories 0, 1, 2, 3, 4, 5, and then the tally. You can skip that altogether, and then the frequency of each class or category. To create the relative frequency column, we divide each frequency by the sum of all frequencies. Now we want to construct histograms of the discrete data in the previous example. The histogram is basically a graph that is used to represent quantitative data, and it's very similar to the bar graph, which is used to present qualitative data. A histogram is constructed by drawing rectangles for each class of data. So the major difference between histograms and bar graphs is the rectangles in the histograms touch one another, but in the bar graph, the rectangles do not touch each other. Looking at the previous example of the number of cars per household, let's create a histogram for this set of data. So this is the histogram that represents our data. As you can see, the width of the rectangles is the same. The height of each rectangle represents the frequency. Those rectangles touch each other. We put the category or the class at the bottom on the x-axis. The frequency goes on the y-axis. For the relative frequency, it is going to be the same, except for replacing the frequency with the relative frequency. So the height of each rectangle represents the relative frequency instead of representing the frequency.